Hi everyone, welcome to the class. Everybody, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. And guys, today is the lecture number 2 of Ionic Equilibrium. So this is a detailed lectures that we are doing for Ionic Equilibrium that will be beneficial for both 2026 and 2027 aspirants, right? So everybody, do let me know in the chat box if I am clearly visible and audible to all of you. Yes, Chandu, Deepa, Shridhar, Shri, Crazy, uh, Sanghavi. Yes, how are you all? Very good evening. Very good evening. Okay, before going ahead, tell me if in the previous lecture you have any doubt, then do let me know in the chat box, like whatever doubt is there. We discussed about KW, we discussed about pH, POH, and we discussed about strong acids, strong bases, two strong acids, two strong bases, one strong acid, and one strong base, right? All of this we have already discussed, right? Now I'll be talking about weak acids, weak bases, and other different pairs that we have, right? Okay, so the first pair that you have here is pH for weak acids. Now, if I talk about weak acids, do you remember in the previous class we discussed about that H positive concentration is equals to this? How many of you remember this? H positive concentration is equals to under root of KaC. Do you remember this? We discussed in the last class that why it is so, right? C is the initial concentration, K is the dissociation constant, and H positive is the concentration of H positive ions, right? Now, from this equation, I'll see what is the value. Now, those who are thinking how it is coming, we know that Ka is equals to C alpha square. We derived it properly. Then we know that alpha is equals to under root of Ka by C, and also what is H positive? That is nothing but C alpha. If you see this here, this is CH3 COH, this is CH3 COO. This is a weak acid, no? Take it as C00. At equilibrium, it will become C minus C alpha, C alpha, C alpha. So H positive was C alpha, right? So that's how you put the value of C alpha here. This is C into under root of Ka by C. This will cancel and it will be Ka into C. That's how we derived this, right? So this is a recap of previous lecture that I have done, right? Now, if you say under root of Ka into C, that is your H positive concentration. Now what you have to do, take log on both sides. Take log on both sides, right? So when you take log on both sides, it is minus, let's take negative log, minus log. So minus log H positive. This is whole raised to power half, right? So when you take the log here, half will come in front, right? Let's not take negative log, let's take positive log only. Negative to I'll put after that, right? Log of H positive, this half will come in front, this will become log of Ka into C. Whenever two things are in multiplication, that log is added, so it will become log of Ka plus log of C. Okay, now we have done this. Now what you will have, add minus all over there. This is minus log of H positive. This is minus half log of Ka. This is minus half log of C, right? If you see this, what is minus log of H positive? That is nothing but that is pH. This is nothing but this is pKa. Half of log Ka is minus log of Ka is log of pK. This will remain minus log of C. And that becomes your formula. The formula is, I'll just write it here. The formula is pH equals to half pKa minus log C. And this is the formula that you must remember, right? This is the formula that you must remember, that how do you calculate the pH of weak acids, right? Okay. No, I'll have one more lecture we will have for ionic equilibrium, right? Okay. Yes. Do let me know in the chat box if that is clear. pH is equals to half pKa minus log of C, right? Now, let's move ahead and do more things, right? That is there, that we have done, right? And this is the formula that I told you, pH is equals to half pK minus log of C. We have also derived this formula, right? Okay. But is derivation needed for the exam? No. But should you know that? Definitely yes, you should know from where it is coming from, right? Because that makes your base very strong, right? Then next is pH for weak bases. It is the same thing. There is no difference in that, right? I'll just tell you here, after solving this, you will have POH is equals to half of pKb minus log C. Similar way, just replace H with OH and Ka with Kb. Everything else is going to remain the same because this particular thing is same. OH negative is equals to under root of Kb into C. If this thing is same, that is also same, right? Okay. Now, if you see this you understood now why it is same. If pH you know, POH you know, then what is the value for pH? pH is going to be nothing but that is pH is equals to 14 minus POH. That is nothing but 14 minus half of pKb. Minus will become plus half of log C, right? That will be the answer. Or you can just, why to remember any other formula? Just remember this thing. POH will be this, pH will be 14 minus POH. Why to remember other formulas? When from one formula you can remember so many things, and why to remember? It's less cramming is better, okay? Less cramming is better. Just remember pH is equals to half of pK minus log C. Then corresponding to this, POH will become half of pKb minus log C when you have weak base. This is when you have weak acid. Okay? Understood? Just remember this one formula, and other you can do yourself as well. Right? Shri Devi, the class has started. Then who is this teaching? This is my ghost or what? Huh? Okay. Understood? Tell me in the chat box. Right? If that is clear for weak bases, what it is, right? And that is the formula, right? That is written for weak bases, right? If you don't want to do these calculative formulas here, then I'll just delete it. Just remember these two pages, right? That's it. Out of this also, this one, this formula for weak acid, for weak bases, just replace pH with POH, pK with pKb. That's it. Right? Okay. Through various, open the link, I get the lecture only. In the side, it will be written Lokesh, right? In the doubt section, just ask for the PDF. Okay? Yes. Now, 600, now let's do some questions on that. Let's do some questions. We have seen the formulas. Let's do some questions. This is JEE Main's 2023 question that you have, right? Okay, no, I'll be teaching that soon. Next week, I'm going to start. The first lecture will be aldehyde ketones, right? Okay, so 600 milliliters of 0.01 molar HCl is mixed with 400 milliliters of 0.01 H2SO4. The pH of the mixture is going to be what? This is what they are asking you here, right? So everybody focus here, right? 600 milliliter of this much HCl. Firstly, tell me what kind of pattern this is. Is this strong acid, strong base, strong acid, weak base, two strong acids, two strong bases, one strong acid, one strong base? What kind of situation you can see here, right? You can see this over here, HCl, and here it is H2SO4. Isn't it a pair of strong acid and strong acid? And what was the definition of H positive in this case? It was N1, M1, V1 plus N2, N factor of 2, molarity of 2, volume of 2 divided by V1 into V2, right? Okay, because normality is equals to N factor into molarity, right? So for N1, V1, this V1 is given to you, amazing. This M1 is given to you, awesome. N1 is going to be 1 because only one H positive is given here. Here V2 is given to you, awesome. M2 is given to you, amazing. 2 H positive are given by H2SO4, N factor of 2 is going to be 2 here, right? Isn't it? Now everything you have, the pH only you have to calculate here. So what you do, apply that formula. H positive is going to be, N1 is 1 multiplied by 0.01 multiplied by 600 plus M2 is 2 multiplied by 0.01 into V2, that is 400 divided by 600 plus 400. If you solve this, this will cancel. 6 plus 4 to 8, right? This is going to be 1000, right? So it is going to be 8 plus 6, that is 14 by 1000, that is 0.01, 0.014, right? That is going to be the H positive concentration. So what is going to be the value of pH? pH is equals to minus log of H positive concentration, that is minus log of 14 into 10 raised to power minus 3. So minus log of 14 you will have to solve here, right? That's why these all values are given to you. So this will be minus log of 14 plus 3. Now minus log of 14, ma'am, how do I solve that, right? Definitely Siva, it's live, right? Definitely Lokesh, I'll teach that. Don't worry, right? Don't worry, right? See, minus log of 14, okay? So log of 14 is what? 14 is either it can be 7 into 2, right? So that can be log of 7 plus log of 2. What is log of 7? It is given to be 0.84 and log of 2 is 0.30. That will be 4, 8, 9, 10, 11, this much. That is going to be the value of log 14. So 1.14, so it will become 3 minus 1.14. I'll hope so that I have done the calculation right. Okay, so yes, it is 1.14 when you subtract from 3. Let me do a little bit cheating. Your ma'am is not good in calculation, I must say. Oh, I hate calculations, guys. Right? I don't know how I end up being a non-medical student, but I hate calculations. Right? That's why I choose chemistry. I'm like, oh my God, thank God. Calculation is not that required. That's why when I was in BSc, I did mathematics, I did physics, I did chemistry. Then I was like, which path? I'm like, I hate calculation. So less calculations will be there. It is there, but it is less as compared to physics and mathematics. I'm like, okay, let's choose this, right? So that would be your answer here, right? And this is a latest question. If you see 2023, it's not like, oh my God, this question has been asked, ma'am, in some 90s, 80s or something. No, it is like 2 years back, this question has been asked. It's quite a simple question based on this simple formula there, and then calculate the value of pH here. Okay, right, everybody? Then let's see JEE 2020 question. Let's see what they have asked you here. To the class 11 playlist. Okay, Lokesh, I'll just definitely do that. Today only I'll see which is where and I'll do that, right? Okay. Thank you, Lakshman. Thank you so much. Thank you so much, right? Okay, so this is Assertion Reasoning 2020 question, that is, the pH of water increases with increase in temperature. Now tell me about this. Yes, students, let me see if you can answer this or not. Let me see, everybody, if you can answer this or not. Who will answer this? Tell me. Who will answer this? Right? Now please add these lecture too. Okay, Lokesh, done. For the pH of water increases with increase in temperature. Okay. The dissociation of water into H positive and OH negative is an exothermic reaction. See, first thing is, they are not talking about that ionic product situation that we did. Do you remember that? See, first I'll talk about the pH of water. Let's talk about that. We know that if you change the temperature, Kw will change. But in case of water, pure water, always H positive. Now remember one thing, we say H positive and OH negative is equals to Kw, right? So what we want to say here, H positive and OH negative is this. So if you increase the temperature, Kw is going to increase. If Kw increases, this will also increase. We don't know. Maybe both are increasing, that's why it is increasing, because it's a water. Water is neutral. So its pH will not change here. Both of them will change, accordingly Kw will change here. So Kw varies with temperature. Nobody is saying that pH varies with temperature. Kw is varying with temperature. So this we can't say that H positive is also varying. That means this is a false statement. The dissociation of water into H positive OH negative is an exothermic reaction. Not at all. I have told you in the previous lecture based on Clausius-Caprion equation, right? What we studied that this is an endothermic reaction. That's why temperature and Kw are directly proportional. So this is also false. So both A and R are false here, right? So this is the full, all of that we did in the previous class. This is Clausius-Caprion equation. And in this equation, we know that if this is positive, that is how temperature and Kw are getting out to be directly proportional to each other, right? Okay, so delta H is definitely positive here, right? Okay, right, everybody, tell me. Another thing based on this, when temperature increases, then we know that this all increases as the reaction is endothermic. So this is this. Now, if I am saying that H positive concentration of T2 is greater, then the pH is going to be less here. If we say the temperature, now it varies, okay? So if I say at a higher temperature, H positive concentration is more, then the pH, we know that pH is inversely proportional to H positive. If this is increasing, then this is going to decrease, right? Okay, right, everybody? So both are false here. Next question, again JEE 2020 question, that is two solutions A and B each of 100 milliliters was dissolved in NaOH and H2SO4. Now this is a case of which one? Tell me. This is which case? Water dissociation is endothermic. Okay, yes, tell me. Now you can take a bet here. Which one is this? Which case is this? Strong acid and strong base case, right? In this case, what I'll do, I'll firstly check which one is greater. So if I see this is V1 and V2 both, and dissolved in this much gram of NaOH, okay, this much gram of H2SO4, the pH of the resultant solution obtained mixing 40 liter of A and this much of B. Wait a minute. Two solutions, each of this was made by dissolving this much of NaOH and this much of H2SO4 in water respectively. Okay. The pH of resultant solution obtained from mixing. Okay. Here first you will have to solve molarity by taking 100 liter. This is not V1, V2. V1, V2 is this. This is V1 and this is V2. They are saying there is a solution A and there is a solution B. Solution A is 100 liter volume and 4 gram of NaOH. Okay. Solution B is 100 liter and this is 9.8 gram of H2SO4. Now, NaOH, what is the value of NaOH molar mass? Here weight is this much. NaOH molar mass is 23 plus 16 plus 1, that is 6 plus 10, 40, right? So write it here, molar mass of NaOH is 40. Molar mass of H2SO4 is what? 98, right? Calculate the number of moles here. You know, number of moles here of NaOH is going to be what? Number of moles of NaOH given mass by molar mass. 40 by 4 by 40, that is 0.1. Number of moles of H2SO4 is what? That is 98 by 9.8 by 98. It will cancel, it is also 0.1. So both of them are 0.1 mole. Now tell me, what is the formula of molarity when you calculate the concentration? Okay, concentration is what? Number of moles divided by volume in liter. If volume here, ma'am, it is given in liter itself, it is given in milliliter, then I'll multiply this by 1000. Okay, so now here what I'll do? I'll calculate the value of molarity of NaOH. That is going to be what? N2, where is N2? 0.1 into 1000 divided by volume. Where is volume? 100. Cancel, this will 1 molar, okay. Molarity of H2SO4, this is N2 is 0.1. This is, it is same na. If number of moles are same, obviously volume is also, yes, that is, everything will be same here, right? Both are 1 molar, right? Both are 1 molar. V1, V2 is given, M1, M2 that you have calculated. This is nothing but M1. This is nothing but this is M2. N1 is given to you how, what is the N factor of base? It is given to you, N factor of base is given to be, you know what I'll take? I'll take base as 2 and I'll take acid as 1, because I have told you it in the formula, I'll take it like that. Okay, so what I'll do here, this is acid, so I'll take it as 1. This is a base, I'll take it as 2. Here, pH of resultant obtained from this much of A. A solution I'm defining it by 2. This I'm defining it by 1. So A solution means this is V2 and this is V1. You can take anything. I'm just, because I told you that formula, taking N1 V1 as acid and N2 V2 as base. That's why I'm doing it like this. Okay, because sometimes students do these kind of silly mistakes, right? So now V1 you know, and you know, this N2 is what? It is 1. And what is N1? N1 is 2, right? Calculate the value of N1, V1 and all, right? Calculate the value of N1, V1. What is the value of N1, M1, V1? That is equals to, N factor of 1 is nothing but it is 2. So this is for an acid, it is 2, molarity is 1 and volume is 40. I think volume was 40, no, it was 10. It was 10. So it is going to be 20. N2, M2, V2 is going to be, N factor is 1, molarity is 1 and volume is 40. So which one is greater? Tell me which one is greater? N2, M2, V2 is greater than N1, V1, M1. That means NaOH is greater than H2SO4. Right? So you can definitely say that overall it is going to be an acidic solution. Sorry, basic solution. So we'll calculate the value of POH here, OH negative here. That is going to be N2 M2 V2 larger minus smaller, N1 M1 V1 divided by V1 plus V2. That is going to be 40 minus 10, no 20. 40 minus 20 divided by V1 plus V2, 50, right? So this is going to be 20 by 50, that is 2 by 5, right? That is going to be the OH negative. POH is nothing but minus log of OH negative, that is 2 by 5. So it is going to be minus log of 2 minus log of 5. Then this is POH, okay? You solve the value of pH by 14 minus log of 2 minus log of 5. That will become 14 plus log of 2 plus log of 5. Now put all the values of log of 2, log of 5 and you will get your answer, right? Yes? Tell me everybody, is that clear? Is that clear? Right? And doing all these calculations, what you will have, why it is coming out to be 6? Wait a minute, 6. Was it 100 liter or milliliter? Oops, this was 100 liters. Oh, I did a big blunder, guys. I thought it's milliliter written. What to do now? I'm not gonna solve this again, okay? This is milliliter written, so then things will be more easy. Sorry, this is liter, na? This is, if it is liter, then it is going to be not multiplied by 1000. Okay, let's do that. I'll just do the corrections here. Oof. This is now 10 raised to power minus 3. This is also 0.1 by 100. This is also 10 raised to power minus 3. Now everything else is same. This is molarity you have, right? Now here you will have the correction of molarity. This will be 10 raised to power minus 3, 10 raised to power minus 3. This will also change here. Let me do that. Okay, 10 raised to power minus 3. This will become, this will cancel 2 into 10 raised to power minus 2. This is 10 raised to power minus 3. This will become 4 into 10 raised to power minus 2, right? Now, this will also change, then everything will change, yaar. Everything will change. So, this is 4 into 10 raised to power minus 2. This is 2 into 10 raised to power minus 2, right? This is V1 plus V2, 40, 50. This is going to remain the same. But this is 10 raised to power minus 2, take it as common. This is 50. This is 4 minus 2 is 2. Okay. So 2 into 10 raised to power minus 2 into 10 raised to power minus 2. Right. Okay. That is going to be the answer. Acha, tell me one thing. Here one more thing. Everything will change. Wait a minute. Everything is going to change here. If you talk about, this is 0.02. This is 0.02. This is 0.04. Right? So you'll have that. Now you'll have to put different value here. So this is also going to change. This will be 2 by 5 multiplied by 10 raised to power minus 2. Then why they have written 6 over here? 10 raised to power minus 3, no? Then 40 minus 20 is going to be 20 into this. Wait a minute, some calculation mistake is there. If I say 10 raised to power minus 3, 40 minus 20 is 20. This is going to be 50. This will cancel. So I'll just delete it. There is some calculation mistake there. Okay? I'll just solve this myself only. right? Okay, see what you will have here. This will be the thing, this will be minus log of 2, right? Minus minus plus log of 5, and minus log of 10 raised to power 2 is 2, right? So this will become 2 minus log of 2 plus log of 5, right? What is the value of pH? pH is 14 minus POH. This is minus 2 plus log of 2 plus log of minus log of 5, right? Then you solve this. This will be 12 plus log of 2 minus log of 5, right? And solve this. Log of 5, wait a minute, log of 5 is 0.69, right? 0.69 here, right? Yes, 0.69 here. This will be 12 plus 0.30 minus 0.69, right? What it is coming out to be, let us see if our answer is coming out to be, it should be exactly same. 12 plus 0.30 minus 0.69. 11.61 it is coming out to be for me, right? 10.6. Where I have done the mistake. Wait a minute. Is it coming out to be for you what it is coming out to be? 11.6 or 10.6? I know why for me it is coming out to be 11.6. Yes, for me too it is coming out to be 11.6 only. And I don't think so any calculation mistake also we have done. Tell me for you what it is minus log of this. Minus minus plus, and that will be plus 2. So log minus, this is plus, this will become minus, this will become plus, this will become minus, this will become 12. I don't know, you guys are also solving it. Now tell me what is your answer coming out to be. Mine is coming out to be 11.6, right? Okay. So now next question is 2023, that is millimoles of calcium hydroxide required to produce 100 milliliters of aqueous solution. 100 milliliters of aqueous solution we are producing. The value of X is what? Okay, assume complete dissociation is there, strong electrolyte is there, right? Calcium hydroxide, which is a strong electrolyte, we are assuming that complete dissociation is there, right? Millimoles of calcium, this millimoles means you have to calculate moles, required to produce this much of volume with this much of pH. Aqueous solution of pH of 12 is this. Okay. Now see, pH is given to be 12, right? I'll just divide it into 3 parts, right? pH is given to be 12. That means H positive concentration is 10 raised to power minus 12, right? That is given to you. Concentration you know, that means molarity you know, volume you know, number of moles you can calculate there. What is the value of number of moles? Molarity is equals to number of moles divided by volume. See, if you want to calculate the millimoles, then this will be in milliliter. See, one thing, ma'am, but whenever it is in milliliter, you said it should be multiplied by 1000. Array, when you calculate the number of moles, here they are telling you it is millimoles, so take directly it into milliliter. If you have to calculate millimoles, then you don't need to multiply by 1000 if volume is given in milliliters, right? Okay, volume is given in milliliters, molarity you have calculated, so it was so easy question only, right? Number of moles will become volume in milliliters into molarity. Volume is 100 and this is 10 raised to power minus 12. That is 10 raised to power minus 10, right? Convert 10 raised to power minus 10 into this value. Um, if it is 10 raised to power minus 9 multiplied by 10 raised to power minus 1, that is equals to 10 raised to power minus 10. 9 plus 1 is this. So you can say this is the value of x, right? Let us see, right? Oops, yaar, why I'm doing these mistakes? pH is given, but we have CaOH twice. Yes, I was just thinking that why this much easy question is given to you. Yes, pH is given, but you have OH negative here. This is CaOH twice, right? That is the problem, na? So POH will be 2, right? So OH negative concentration is going to be 10 raised to power minus 2. Now things are going to change here, right? Okay. So now OH negative concentration you have. When you have OH negative concentration, then you will obviously put P. Now see one more thing. This is CaOH twice, right? This will be dissociated into this and this. Okay. See. Achha, full fledged so we have not seen only, so directly I did, right? Okay, you have CaOH twice here. This is OH negative here. See this thing very carefully. Now, if you see, this is OH twice, concentration of this thing is given to you. They are asking you millimoles of calcium hydroxide. If this is x, then this is going to be 2x. So that means if this is 10 raised to power minus 2, then this is going to be 10 raised to power minus 2 divided by 2. This is going to be half of that. So it will be equals to, it will be multiplied by 0.5 here, right? Because that is half of it. So it will be 5 into 10 raised to power minus 3, right? It was also easy only, but one silly mistake can, lead you to there. So this concentration, because they are asking you millimoles of not H positive, not OH negative, they are asking you millimoles of CaOH twice. So that's why concentration of CaOH twice you have to see. If 1 mole is giving 2 OH, then this much will be give you half of this. That's why I multiplied it by 0.5 here, right? Now you do the same thing. What was the number of moles? It was equals to, number of moles were equals to volume in milliliter into molarity. Molarity meaning concentration is this much, volume is 100, concentration is 5 into 10 raised to power minus 3. That will become 5 into 10 raised to power minus 1. So x is going to be 5 here, right? So this is going to be 5, right? So answer is 5 is the correct answer, right? Okay, yes everybody, understood? Tell me everybody in the chat box, right? Okay, now let's move ahead with common ion effect, right? So the questions are not difficult in case of pH. I say you were just getting scared of ionic equilibrium. The questions are not on the difficult side. Questions are easy. They are just direct formula based questions are there. It's not like if you have not done the chapter, definitely you will find it difficult. But if you have done the chapter, you will eventually find it easy only, right? Because the questions are not tricky or like too much calculations. This thing is not there in this chapter, right? So let's see common ion effect. Common ion effect, that means we want to say that if let's say one person is strong, there is a strong person and there is a weak person. So let's say you are not that confident, right? But still, when you're alone, when you're in your home, you try to be confident, you try to behave confidently in front of others. Let's say there is some strong person in front of you, one of your cousin who is super duper confident. When they joins you, then you feel even more suppressed. Then you feel like, oh my god, now to I can't do anything. Why? Because if I do anything, he will make fun of me, right? So this also has happened with me. So when you are like underconfident, you still try, but let's say if I ask you go on stage, then you will feel even more scared. This is what is happening with this weak electrolyte. So if we say there is a weak electrolyte, there is a strong electrolyte, what will happen if both of them have something in common? If both of them has a common ion, then this strong is going to suppress this its concentration. I'll tell you what exactly. So we are saying that the common ion effect is the effect that suppresses the dissociation of an electrolyte when another electrolyte which contains an ion which is also present in the first electrolyte is added, right? So what we are saying that if you have, let's say, let's talk about this AB. This give rise to A positive and B negative and B negative. Now you will feel like you are doing Lee-Chartler principle. Let's say common ion is A positive, right? Let's take another example. Let's take proper example only. Let's say you have CaF2, right? Here Ca2 positive and you have 2F negative, that is undergoing dissociation. You have added NaF also here, that is also undergoing dissociation. Because this is a strong electrolyte, this is giving you full F negative ions here. So these concentration of these F negative ions are increasing here. Why they are increasing? Earlier not so much dissociation was there, but now the dissociation is F negative ions are increasing because of NaF. When product side is increasing, it will try to move in the backward direction. That is why the reaction moves backward according to Lee-Chartler principle, and we can say dissociation decreases. Okay, that's how common ion effect is going to suppress the dissociation of the previous electrolyte, right? Okay, yes. So next, now why I taught you common ion effect? Because now you're going to see the combination of weak and strong bases, like all these things, right? So that is why common electrolyte will be H positive, OH negative. These are going to be common electrolytes. So let's see. Let's assume that the concentration of weak acid of HA is this, and that of strong monobasic acid is C2. Tell me, in weak acids what we used to do? There was no 100% dissociation. Take it as C. Let's say they have asked us to take C1. Weak acid concentration is C1. This is initially 0. This is 0. Right? This will be C1 minus C1 alpha. Let's say alpha is the degree of dissociation of weak acid. Strong acid is 100% dissociated, so alpha will be 1 there. So we are not taking alpha for strong acid. Right? So this is C1 alpha. This is C1 alpha at equilibrium. At equilibrium. Right? Then if I talk about H positive is also coming from H positive from strong acid is C2. Ma'am, why it is C2? Ma'am, if here it is C1 alpha, there it should be, ma'am, C2 alpha. But alpha is 1 there, so that's why for 100% dissociation, all of acid is getting converted to H positive. That means the concentration of H positive from strong acid is going to be C2. So you are going to add here C2. Why you have added? Because of simultaneous equilibria. Do you remember we did simultaneous equilibrium, chemical equilibrium, that whenever two things which are common in two reactions, the concentration in both of them will be added. So this C2 is from acid, strong acid. The C1 alpha is from weak acid. Okay? Because they are taking place in one beaker, so you'll have to add the concentration of both of them. Right? Okay. Now what is the value of Ka? Tell me, what is the value of Ka? Ka is going to be strong acid and strong bases. Wait a minute. No, it is, I think by mistake it is. right? This though we have done before also. This is by mistake, right? See. Let's see Ka. Ka. What is the value of Ka? Tell me. Product by reactants, isn't it? So what is products here? Tell me. Product is what? Product is H positive A negative by Ha. H positive A negative by Ha. By Ha. What is H positive? Ma'am, H positive is C1 alpha plus C2. This is C1 alpha, right? This is C1 alpha plus C2. This is C1 alpha and this is going to be C1 1 minus alpha. C1 will be cancelled here. This will become C1 alpha plus C2. C1 alpha plus C2 into alpha divided by 1 minus alpha. If the concentration, if I say if alpha is very, very less than 0.05, then we can say this over here that Ka equals to C1 alpha plus C2 multiplied by alpha, and that is going to be your answer for Ka when they have given you that there is one strong acid, there is one weak acid, then they have given you the dissociation, degree of dissociation of weak acid, that is alpha. C1 is the concentration of weak acid, C2 is the concentration of strong acid. Okay? Tell me. Clear? Okay. Tell me. Is that clear? Now, mixing of two weak acids. Now, let's say two weak acids are getting mixed here, right? Two weak acids. Now, someone will say, ma'am, what about, ma'am, if two strong acids, if ma'am, two strong base, ma'am, if there is one strong acid and one strong base, one weak base and one weak acid. So, we'll just write it here. For one strong base and one weak base, it is going to be Kb is equals to C1 alpha plus C2 into alpha. Same formula will be there. Here Kb will be there. Here C1 is what? And also one more thing guys here. What is the value of H positive? That is C1 alpha into C2, right? So we'll put all this value and pH will be according to this. If I say H positive concentration is C1 alpha plus C2, this is H positive value, right? Then your pH value will be this one only. pH is equals to minus log of C1 alpha plus C2. That is going to be the value of pH here. Okay, that's how you're going to calculate the value of pH here. Right, everybody? Understood? So, you don't have to cram that much. Okay, no issues. Right, so let's talk about two weak acids. Two weak acids, what they are. Now, when you focus on weak acids now, maybe, if you see conceptually, then you will not find it difficult. If you directly see it in the book, then you will definitely find it difficult, right? So, let's see how we will do this. Same pattern, concentration is C1, this is 0, this is 0. Here concentration is C1, alpha is alpha 1. Here it is C2 and this is alpha 2. Okay. Now, if you see, here it is C2, this is 0, this is 0. At equilibrium, what we used to do? C1 minus initial concentration into degree of dissociation. Initial into degree of dissociation multiplied by stoichiometry. Initial into degree of dissociation multiplied by stoichiometry. What about this one? C2 minus C2 alpha 2. This is C alpha 1. This is C alpha, 2. 2 na? C alpha 1, C alpha 2. Now tell me which of them is common. What is the common thing here? Can you tell me which is the common thing here? Which is the common thing here? Tell me. Which is the common thing here? If you see H positive is the common and the one that is common will be shifted here and there. So here you will add C alpha 2 and here you will add C alpha 1 because this is going to be common in both the cases, right? Okay. Now this is the whole scenario that you have to remember. Now if I see overall H positive concentration here is C alpha 1 plus C alpha 2. C1 alpha 1 plus C2 alpha 2. This is also why we have written CC here. This would be C1, this would be C1, this would be C2, this is C2. Okay, this will be C2, this will be C2 and this will be C1. Because blue here it is C2, constant C2, C2 minus C2 alpha 2, C2 alpha 2, C2 alpha 2. This is C1 alpha 1, C1 alpha 1. H positive is common, so that's why we have added H positive concentration in both. Right? Okay, I can see few students are here. Very few students. What is the problem, guys? What is the problem? Tell me. Acha, now see this thing. H positive concentration is given to you. That we have. That is going to be C1. Wait a minute. That is going to be C1 alpha 1 plus C2 alpha 2. Then pH is going to be minus log of C1 alpha 1 plus C2 alpha 2. Okay? Understood? Right? So, this is what we are going to do here. Right? And that is going to be our value. So you can see H positive is C1 alpha 1 plus C2 alpha 2. Now, if the dissociation constant for one of the acid is very much high, if one of the acid has dissociation constant very high, that means let's say Ka2 is very greater than Ka1. And also, what is the value of Ka2 and Ka1? If you see this here, what will be the value of Ka2 and Ka1? Okay, if you see this value, Ka1 is going to be C1 alpha 1 plus this multiplied by C1 alpha 1 plus C2 alpha 2 multiplied by C1 alpha 1 plus C2 alpha 2 divided by, this is going to be divided by C1 common 1 minus alpha 1. Okay, C1 will be cancelled. It will be alpha 1. C1 alpha 1 plus C2 alpha 2 divided by 1 minus alpha 1. You can also take 1 minus alpha 1 as you can neglect it if alpha value is very, very less. Similarly, the value of Ka2 is going to be C2 alpha 2, C1 alpha 1 plus C2 alpha 2 divided by 1 minus alpha 2. It will be cancelled. This will become alpha 2 C1 alpha 1 plus C2 alpha 2 divided by 1 minus alpha 2. Now, if they ask you take the ratio of these two acids, dissociation constant ratio of these two acids, that is going to be, this is going to be alpha 1 C1 alpha 1 plus C2 alpha 2 divided by 1 minus alpha 1 divided by alpha 2 C1 alpha 1 plus C2 alpha 2 divided by 1 minus alpha 2. This is going to cancel. This will be alpha 1 by alpha 2. This will 1 minus alpha 2. This is 1 minus alpha 1 and that is going to be the ratio here. Right? Okay? Right? If they ask you to take the ratio here, then you will take it this way. Right? But do you have to remember all of that? No, if they give you, you can directly do this. Because very rare chances are that they will give you the question from here, right? So if you see, if I say, they are saying that if degree of dissociation of one of the acid is very much high. So for example, that second acid has degree of dissociation very high. If dissociation is very high, then alpha will be approximately equals to 1. Right, so here alpha 2 will be approximately negligible here, and that is the reason this approximately becomes equals to C1 alpha 1 only, right? Okay, the dissociation constant of one of the acid is very much greater than that of the second acid, then contribution of second acid will be neglected. If let's say, okay, one thing, if I say one of them is strong acid, then this will become equals to 1, then this will become C1 alpha 1 plus C2. This is the case of strong acid and weak acid, right? That we have discussed before also. Now they are saying if both are weak only, but one is still better as compared to other, then what will happen? Then in that case, this thing will be neglected. This whole thing will be neglected. Why? Because the contribution of second acid, H positive contribution from second acid is completely 0. That is why H positive is becoming C1 alpha 1, right? Okay. Another point is, if water is again considered the third weak acid in the solution of two weak acids, water is also considered here, then Kw will be added here, right? Okay, understood? Tell me everybody if that is clear. H positive is becoming C1 alpha 1, that is the same that we have discussed before. H positive concentration is becoming this. Okay, yes everybody, tell me. Yes everybody, if you see this over here, right, this is Ka1, this is Ka2. So H positive concentration is coming out to be C1 alpha 1 plus C2 alpha 2, which is nothing but that is equals to under root of Ka1 C1 plus under root of Ka2 C2, right? Okay. Now let's see the next thing here. From the similar concept, if you see from the similar concept, Kb1 by Kb2 is equals to alpha 1 by alpha 2, and OH negative concentration is going to be this. So I'm going to write all the things here. Just like guys, here we have calculated Ka1 and Ka2, right? So here what it is coming out to be, if alpha is very small here, this will be cancelled, right? This will become alpha 1 by alpha 2, right? Ka1 by Ka2 is coming out to be alpha 1 by alpha 2. So similar is the case for Kb1 by Kb2, that is alpha 2 by alpha 1, right? So that is why similar case here. This also I have told you, like here you have H positive concentration, where it is, C1 alpha 1 plus C2 alpha 2. Similarly here it will be C1 alpha 1, C1 alpha 2. Now the question is, ma'am, how you are defining Kab here? Sorry, Ka na ke pH, wait, in terms of this, wait a minute, H positive concentration in terms of this, how you are defining that? Ka1 C1 plus Ka2 C2. Okay. Either so you can remember as it is, just like for weak acid, for one weak acid it was H positive is equals to under root of KaC. For two weak acids it is going to be this. Or what you can do in the similar line, you can calculate this as well, right? But I will not get into that much derivation because that is not needed, right? You just have to understand the last page here, that is Ka1 by Ka2 is equals to alpha 1 by alpha 2, right? This is one. H positive concentration is C1 alpha 1 plus C2 alpha 2, or it is Ka1 C1 plus Ka2 C2. Just remember these points here. That's it. Just remember these points here. This is when you have two weak bases. This is when you have two weak acids. Right? Okay? Chalo. Now let's see next, that is pH on dilution. Now if I talk about dilution, when you dilute, then remember this particular formula, that law of dilution says that M1V1 is equals to M2V2, that is applicable for dilution. When you dilute, right, M1V1 is equals to M2. The number of moles will remain constant. The core concept here is that when you dilute, the number of moles of that compound will not change. So number of moles in first case will be molarity of 1 by volume of 1. When you add water, volume will change, molarity will also change, but the number of moles are going to remain constant. Okay, so that's why M1V1 is equals to M2V2. Now let's see the next question, that is calculate pH of the solution. Let's see this one. Let's see this one. I say, beta, I am not feeling like teaching, like very few students are there, right? Then I'll not take buffer solution today, right? I'll take buffer solution in the next class, because so much energy I'll put into so few students, so it also demotivates me, right? Then I don't feel like teaching, right? So I'll cover buffer solution in the next class itself, right? Calculation of solution obtained by mixing equal volume of 0.02 molar HOCl and 0.2 molar CH3COH solution, giving that this is this. Now for this you must know which is a strong acid, which is a weak acid. So if you see, HOCl is a weak acid. HOCl is weak. CH3COH is a weak acid. So here they have given you Ka for both. Then they are asking you pH here. Concentrations are also given to you. So pH is H positive concentration is quite simple here. That is given by under root of Ka1 C1 plus under root of plus Ka2 into C2. So this will become Ka1 is what? For this acid it is 2 into 10 raised to power minus 4, right? And for this acid, HOCl concentration is given to be what? 0.02, right? 0.02. And here Ka2 is given to be what? It is given to be 2 into 10 raised to power minus 5. Concentration is given to be 0.2. So you'll just put the values and get your answer here. If you see, the pH value is going to be minus log of H positive here. Solve this, put the value of pH here, and you will get your answer here, right? Put all the values, get your answer here, right? Okay. Then there is di and polybasic acids, di and polyacidic bases, right? Let's talk about that, right? Why does pH increase on dilution but not always for weak acids? Why does pH not always change by log 10 when dilution is tenfold? I didn't get your concept. pH on dilution for strong acids. I didn't get your concept, Louis. What you are asking, I didn't get it only. Right? What you are asking. Right? Okay, see this. Now, let's see this question, that is di and polybasic acids and di and polyacidic bases. Polyacidic, that means more than one H positive, more than one OH negative they are giving, right? Some acids like oxalic acid, sulfuric, phosphoric acids have more than one ionizable proton. Such acids are known as polyacidic or polyprotic, right? So let's talk about di, which are giving you two H positive here. Let's say in first case, when one proton is dissociated, you will have, let's say this is the overall reaction that we'll not see. First we will see when one H positive is given, it is giving you HA, HX negative. When we see this Hx again gives one H positive. This will be converted to X2 negative. There is no H positive remain to give. And if you see overall reaction, when directly it gives 2H positive, then the reaction will be this. Accordingly, Ka, Ka1 and Ka2, you will put all the values, and what you will see that Ka is equals to Ka1 into Ka2. That is the formula that we have for polybasic acids, right? That overall Ka is equals to multiplication of the Ka of individual steps here, right? Okay, yes everybody. Now I think, okay, let's talk about this as well. If Ka and Ka, they ask you in terms of like C1 alpha 1, then what you will do? Now here if you see, we have considered that there is, let's say there is weak acid, let's say this is a weak acid. Because for weak acid only we'll see alpha, otherwise we will not see alpha for strong acids, right? Strong acid to 100% they will be dissociated, right? Wait a minute. This is actually not written correct. This is not correct. This should not be written like this. This is incorrect, okay? This is not correct. Let me just correct it. It should be written like this. Because we want to calculate Ka1, na? So it should be written like this. It is giving you 1 H positive and it is Hx negative. Okay? Now see, concentration of H2X is C1. Okay? Initially it is 0, this is 0, this will become C1 minus C1 alpha 1, dissociation of first reaction, this will become C1 alpha 1, this will become C1 alpha 1, right? Now if you see, Hx here is what? C1 alpha 1, so you will put C1 alpha 1, initially this was C1 alpha 1 only and this was 0, right? Now because here what is H positive, that was also initially there, na? Before this reaction has started, it was H positive and this was already there in the reaction, that is this much amount. Now let's see what you have done. You have taken out C1 alpha 1 minus initial concentration multiplied by second dissociation. C1 alpha 1 is the initial concentration multiplied by second dissociation. This will be C1 alpha 1 addition of whatever you have subtracted here, C1 alpha 1 alpha 2. This will become C1 alpha 1 alpha 2. Okay, tell me if that is clear what we have done. Initially it is H2X, you have C1, this is 0, this is 0. This you will say initial concentration into dissociation, subtract, right? This as it is here. This is initial because they are already present. Now subtract, initial multiplied by second dissociation. Now add this value here, right? Okay, understood? Now see one thing here. This is given. H positive concentration has to be same in both the cases. So here also you will add C1 alpha 1 plus alpha 2, right? And here also Hx negative is also in both the cases. So here also you will subtract C1 alpha 1 and alpha 2. So what is going to be the value of Ka1 and Ka2? Ka1 is going to be product, that is C1 alpha 1. See, C1 alpha 1 you can take common as well here. C1 alpha 1 you can take common. This will become 1 plus alpha 2. Okay? Here also you can take C1 alpha 1 common. This will be okay, yes. Here also you can take C1 alpha 1 common and this will become 1 minus alpha 2. divided by, this is C1, take C1 common, this is 1 minus alpha 1. 1 minus alpha 1 you have as it is, this will become C1, C1 will cancel, this will become C1 alpha 1 square 1 minus alpha 2 square divided by 1 minus alpha 1. Why? Because a plus b multiplied by a minus b is nothing but a square minus b square. Okay? That is how you have the value of Ka1 here. That is how you have this value here. Okay? Now I'll talk about, similarly you have here this thing, that is what? Ma'am, this is Ka2. So how do I answer Ka2? Ka2 in the similar lines. Here this is the product. Product is H positive, that is C1 alpha 1. You take it common. This will become 1 plus alpha 2. This is C1 alpha 1. This is C1 alpha 1 into alpha 2 divided by C1 alpha 1. You take common. This will become 1 minus, wait a minute. Acha, there to C1 I have taken as common. Here C1 alpha 1 will be common, 1 minus alpha 2 it will be, yes. 1 minus alpha 2. Now C1 alpha 1 will cancelled and this will become 1 plus alpha 2 divided by 1 minus alpha 2 multiplied by C1 alpha 1 into alpha 2. That is the value of Ka2. Okay? Tell me. Thank you. Understood now what I am doing here? So nothing we are doing, I am doing the same thing everywhere. I am not changing the concept. Throughout buffer solution, salt, hydrolysis, KSP, you are going to do the same thing, right? This is you, when you see this, you get scared of this thing. But see how, I have not crammed it any time, right? I am solving in front of you. If you give me this, ma'am, tell me what is here directly. I will not be able to tell that. Why? I have not crammed it. Neither you don't have to cram it, right? Just remember that concept C100 initial multiplied by alpha you have to subtract and you have to make all the concentration which are common same. That's it. That's the only concept that we have. Okay? Right? When you multiply this now, overall Ka, when you will find everything, you will feel that yes, they are coming out to be same. Right? Okay? So now let's move. Next is this we have done, right? This all we have done. Acha. Now they are saying if H positive total, what is the total H positive? C alpha 1 plus C alpha 1 into alpha 2. C alpha 1 plus C1 alpha 1 alpha 2. Isn't it? We have calculated the same thing, right? This much you should remember. This you can't do it every time in the exam doing all of this. This much you should remember that what is H positive for this case, so that you don't have to do the derivation in the exam. That's why you have to remember this thing. Only this thing, okay? Other things, pH calculation is simple. If you know H positive, you can easily calculate the value of minus log of pH, right? Then, if I see here, here they have taken C, I have taken C1, that is the difference. And if I say Ka, approximately if Ka1 is very greater than Ka2, so alpha 2 will be ignored here, then this whole term will be ignored. So H positive will become equals to C alpha 1, just like we did in the previous case, right? Okay, tell me. Now let's see this question here, that is the first and second JEE 2007 question it is, which is saying the first and second association constant for an acid H2A are 1 into this Okay. Overall, it's simple. It's the very, very simple. Ka is equals to Ka1 into Ka2. What's the big deal about it? Right, this is Ka1 is given to be 1 into 10 raised to power minus 5. Ka2 is given to be 5 into 10 raised to power minus 10. You solve this and you will get your answer, right? So answer is going to be D is the correct answer here. Okay, right everybody? Done. Achha, this is the homework question only, right? So, see, buffer solution itself is a very big topic. So, I am thinking that I'll take your class next Monday. I'll take your class. Huh? Shall I take your class on Monday? Tell me. On Monday, I'll take your class. On Tuesday, we'll then complete the chapter. Right? Okay? Tell me everybody. Monday, I'll take your class for buffer solutions, and by Tuesday, we'll complete the chapter. Right? Done? Definitely I'll teach, but that I'll not teach because this particular class is for JEE 2027 aspirants as well. That's why I'm teaching in different, I'm teaching in like different lectures, because I know in one shot for 2027 it is going to be too much, right? But aldehyde ketones I'll teach in 1 or 2 parts, right? Okay, right? Chalo. Now buffer solution I'll teach you on Monday. Solubility also I'll teach you on Monday. Buffer solution and solubility. Then last will be for your buffer solution and solubility I will teach you. Then salt hydrolysis is also, like, it's not very big topics, but yes, you can say that salt hydrolysis is going to take 1 hour if you want to study in detail, right? Okay. No, I'll not give you any gap, but tomorrow's it's Sunday, right? Monday and Tuesday we'll finish this, right? I'll take 1 class on Monday, I'll take 1 class on tomorrow. Tomorrow I am not available, so tomorrow I won't be able to teach, right? Monday and Tuesday we are going to cover this particular lecture, and I want attendance, guys. Otherwise I don't feel like when I don't see students interacting, students are not there, even I feel like, so much hard work we are doing for you. So at least be present in the class, right? So Monday I think 6 p.m. and Tuesday 6 or 9 p.m. I'll take your class, right? Okay, chalo. Okay, great. Chalo. Okay then, guys, bye bye, and I'll see you all in the next class. Bye bye. And before going, let me remind you for one thing over here, that is, wait a minute. Today is something very interesting I'm going to do at 9 p.m. I'll just give you the link for that thing. Wait a minute. So if you see this over here in the description box, you will see, first thing is, here you will get your doubts, everything you will get here, right? You want to have the PDF, you will get here. Ask with any doubts over here. Second is, I'm going to take your webinar. So click over here and fill in your phone number. This webinar is completely free of cost, and here I'm going to give you some secrets for next 40 days, and this I am taking up for JEE 2026 aspirants specially, right? And JEE 2027 aspirants as well can join, because some interesting things I'm gonna tell there. And guys, over here you will see one more thing, that is, wait a minute, yes. Where is our... Okay, I think it's, I'll just attach this over here as well, right? So what you will see here, right? Yesterday's session, let's pick yesterday's session, right? So in this session, what you will see over here, that in the description box, what you have here, wait a minute, yes, Eclavier Rank Booster Test Series. Click on that and you will get, right, what you will get, that is just at 999 rupees. That's it. And here you will get 11 part test, 25 full test, 3 hours each test will be there with 75 questions. And apart from that, you will also get 93 high weightage topic test, which you can attempt anywhere, anytime, right? Okay. Yes, students. So that's all the things you are going to get in just 999 rupees. So go and avail the offer, get it done, and yes. So that's it, guys. Now I'll see you all in the next class. Till then,